Bearings are basically the direction, or basically it's an angle that gives us the direction of a particular movement. And this always happens starting from directly north, okay, in a clockwise direction. So please remember that, starting from directly north in a clockwise direction, okay? So I'll show you over here on this diagram what that means. So if we're starting from that particular point, okay, and I want to examine the movement from that point to a particular point, okay? So I'm going to draw my direct north, okay? I always like to draw my direct north. And then if it's on a bearing of this particular angle, okay, clockwise direction. So if this is the bearing, or if this is the angle of the bearing, that means this will be the direction of the movement from that particular point, okay? So if this is the bearing given, this is the length of my movement. All right, that's basically what it is. Now, guys, if you're given a situation when it's directly due east, this is east, okay? If it's directly due east, that means this is the angle, isn't it? Okay, this is the angle, and hopefully you guys can say that's 90 degrees. So from north directly due east, okay, from that particular point is going to be 90 degrees. Now with bearings, we like to represent that as a 3-digit number, okay? So instead of just writing 90 degrees, for bearings, I like to represent that as 90 degrees. Okay, so you'll often see that when we're talking about bearings. Now, I know some schools, they use the T at the end. So you'll often see some textbooks using this T at the end of that angle. That just means true bearings, which is basically the same thing, okay? So just because it puts the T there, there's nothing different, there's nothing special about it. It's just talking about bearings in general, but it's just a little notation that's representing bearings, okay? So in today's lesson, I'm just going to be using my standard form of 90 degrees, or just the 3-digit number, okay? So because that also represents bearings. Now that's the bearing for directly due east. Now if we're talking about directly due south, from that point, that's due north, to south is going to be that angle, isn't it? Okay, so that's the angle or the bearing that represents direct south, okay, which is, hopefully you can say, is 180 degrees. So that's the bearing directly due south. And similarly, if it's directly due west, this is the bearing, isn't it? Okay, that's the angle of the bearing to west, okay, directly west. Okay, so, and that's 270 degrees. Okay. Now I hope some of you can catch the reason why we're using bearings. Now, I'll give you the reason why we're using bearings into our questions. That's because, say you're given that a movement happens towards northwest. Okay, this is northwest. Say it's moving towards northwest, but northwest is not only there, it could be here, or it could be here, isn't it? Yeah? So all three positions represent northwest. Anything that happens in this particular quadrant is northwest, isn't it? So that's not a very exact or precise direction, isn't it? It's a very rough direction. But if we use bearings as an exact figure or a number, yeah, we can find the exact precise direction of a particular movement. Okay, that's why we're using bearings, to be very precise. That's basically it. And guys, just note that, you must note that the bearing cannot be a negative value, okay? It's always going to be happening within this revolution, okay, in a clockwise direction. Okay, so it cannot be negative. And the highest bearing you can have is 360 degrees, and that's when you're coming back to your original north, okay? So 360 is the highest bearing. You can't go over that. It can't be higher than 360, okay? And it cannot be negative. Just keep an eye on that, all right? So that's basically what bearings is. So hopefully that makes sense. Just rub this off now. So have a look at that now, and we'll move on to some questions. So starting with question 1, sketch the diagram when M is on a bearing of 315 degrees from P. Okay, now guys, always keep an eye on what the starting point is, or where it's coming from. In this case, it's from P, okay, and it's moving to M on a bearing of 315 degrees. So I'm going to sketch this, okay, okay? So what I'm going to do is always start from my starting point P. So I'm just going to put a little dot there for P. That's my starting point P. And I always like to draw a direct north, okay? So remember how bearings is always starting from north. So I'm going to draw my north there. So that's north, and it's moving in a direction of 315 degrees. So from north in a clockwise direction, I'm going to go 315 degrees. I don't know, it's probably approximately there. That's going to be 315 degrees. So from P to M, this is the direction. Okay? That is M. Okay, so this particular point is M. But guys, this question only gives us the direct direction, okay, of the bearing, because it gives us 315 degrees. So in this question, we only know what the direction is. So we cannot determine what this length will be. So just draw a rough length of M. So M could be there, M could be even here, and could be further outwards, okay? We can't really determine from this question, so I'm just going to draw a rough position there for M, okay? So that's basically it, guys. I'll just show you a neater diagram. That's what it's going to look like. So P, I always like to start off my north. It moves in a 315 degree angle, and there's my M. Okay, that's basically what I did here. I just wanted to show you a step-by-step process of approaching this kind of question. So that kind of diagram will lead you to a full mark, okay, full mark question. So have a look at that, guys. That's the sketch for question 1. So let's move on to question 2 now. So question 2 says X is on a bearing of 30 degrees from Y, okay, and it's again asking us to sketch this diagram. So the 30 degrees, that just means 30 degrees, but remember how for bearings we write as a 3-digit number. So X is on a bearing from Y, so our starting position will be Y because it's from Y. So again, I'll do the same thing, put a dot there, that's going to be my Y, and my next step, I always draw my north upwards, okay, it's going to be directly upwards, isn't it? That's my north. Now we're on a bearing of 30 degrees, or basically 30 degrees you can think of. So approximately there, I think that's roughly 30 degrees, isn't it? So therefore X from Y is going to be in a direction of that. So this point here is going to be X, okay? That's basically it. This is the direction of Y to X, or basically X from Y. Okay, and again, we don't know what the length of XY will be because it doesn't mention, so just draw a rough position of X. Okay, so I'll just show you a neater diagram. That's what it's going to look like. Alright, so hopefully those steps made sense. Always trying to keep the same steps as I did, and that will lead you to a perfect sketch. So have a look, guys, that's question 2. So hopefully you're getting the hang of this now. Okay, let's move on. So question 3 says a plane flies 100 kilometers due east, then 125 kilometers due north. Find its bearing from its starting point to the nearest degree. Okay, so this is more of an application question. It says a plane flies 100 kilometers due east. So I'll just draw the diagram again. If that's the plane, let's represent as P. 100 kilometers due east. So what I'm going to do is start off by drawing my north. I always like to start off by drawing a upwards north, okay, direct north. And then 100 kilometers due east. Due east means this way. That's east. And it's going to be on a 90-degree bearing, isn't it? Because due east, directly due east, means a 90-degree bearing. Okay, so this time it gives us a length. It says 100 kilometers. So from P to due east is going to be 100 kilometers. Okay, so I can label that. Now, then it moves 125 kilometers due north. Due north means directly north. Okay, so from this point, it's going to go directly north. Okay, we'll just label that as north. Okay, so this is our finishing point. Okay, this is east, this is north, this is our finishing point. Finishing. Okay, so goes east, then north. It says 125, so I'll label that as well. 125. Okay. Now what we need to find is its bearing. So this time we have to actually find the bearing. From its starting point, that's the starting point. That's our finishing point. So if I just draw a line through those 2 points, okay? The bearing from its starting point, remember how we always start from due north? So from north to our finishing point is simply this bearing here, okay? That's the bearing of its starting point to its finishing point, okay? That's the bearing. So have a look, guys. And basically, please don't make a mistake of saying that this is the bearing, because that's not the bearing. Remember how I said, always keep repeating that the bearing always happens from direct north, okay, in a clockwise direction. So starting from this north, okay? That's why I'm drawing a north all the time. So have a look, guys. I'll just give you a better diagram. That will be a better diagram. So that's what it looks like. Yep, and this is 90 degrees since it's perfectly due north, so that will be a 90-degree angle. Okay, and I'll rub this off. So have a look at the diagram. So you must be able to draw what the diagram is in order to try the questions, okay? Don't try to attempt and go for the question straight away. Always draw a diagram with bearing questions, okay? Because it's crucial, okay? So have a look at that diagram. Now guys, what I'm going to do to find the bearing, theta, okay? What I'm going to do is, because this is already a built-up triangle, this is a right-angle triangle, I'll just call this angle BX. Okay, that will be X. And I'm going to use some trigonometric ratios because this is a right angle triangle. And once I've found that angle, I might as well subtract it from 90 to get that theta, because this is 90, wasn't it? Because this was directly due east. So this angle is 90, so I can find theta that way. I guess I'll just show you those steps. So I'm going to say, well, look, we've got this side, we've got that side. This is opposite side, this is the adjacent side of X, isn't it? Opposite adjacent, we use tan, don't we? Okay, so I hope you remember this stuff. Tan X is opposite over adjacent, so 125 over 100. I'll just simplify that as 1.25, okay? And therefore, tan X is 1.25. How do we find X, sorry. X is going to be tan inverse 1.25, okay? Or in your calculator, just press shift tan 1.25. So put that in your calculator, guys, and check what your answers are. And you'll probably get roughly 51 degrees to the nearest degree. Okay, put it into the nearest degree because they ask us to put it in the nearest degree. So that's X, 51 degrees. So this angle here is 51 degrees. So to find theta, what do? 90 minus that angle, X. Well, we found X. X is simply 51. So we're going to go 90 minus 51, which is simply 39 degrees. So theta is 39 degrees. Therefore, the bearing of the plane from the starting point is 0.39 degrees. So always put that extra 0 at the front to make it into a 3-digit number. Okay, so have a look at that, guys. So hopefully the working out wasn't too difficult. Have a look at that. Let's rub this up. And that's the answer, okay? 0.39 degrees is the bearing, okay, from the starting point. So have a look. And we'll move on. So question 4 says a ship sails on a bearing of 140 degrees from Sydney for 250 kilometers. Okay, how far east of Sydney is the ship now to the nearest kilometers? Okay, so let's interpret the question and put it into a diagram. A ship sails, this is the bearing, so this is the direction we're going to consider, from Sydney. So from Sydney, okay, so say starting from Sydney, that's Sydney, and it's moving in a direction of 140 degrees. So again, I'm going to draw my north. This 140 degrees is an obtuse angle, so it's going to be roughly there, okay, maybe that way. So that's going to be the angle of 140 degrees. So therefore, the ship from Sydney sails in this direction, okay? And that point there is going to be our finishing point. I'll just let that as finishing point F, and it's on 250 kilometers. So the length here is going to be 250 kilometers. Okay, so it gives us a length. Now it says how far east of Sydney. This is the Sydney. This is the ship now. Okay, I'll just sort of say now. That's the ship now. And it says how far east from of Sydney. So this is a ship. This is the direction east, isn't it? So from Sydney, this will be the direction of east. So that will be the length of how east the ship is from Sydney. Okay, does that make sense? So the ship is approximately here. So perfectly east is going to be that particular distance. Okay, so I'll just show you on my diagram over here. That's exactly what I drew. So therefore, this direction here, guys, I'll just highlight that. It's going to pull up X, okay? Because we want to find how far east. So that's going to be X. That's what we're looking for. Okay, how far east. So have a look. I'll rub this off. So hopefully you got the step of how we approach this question, okay? Because drawing the diagram is very important, as I said. So this is the length of what we're going to be looking for. And we're going to put it into the nearest kilometre. Now what I did was label this as theta. This angle is going to be theta. I'll just rub this off so you can actually see better. This angle is theta, and the reason why I'm finding theta, okay, is because I can find theta by doing 140 minus 90 degrees. Okay, because if I find that particular angle, it's going to be a little bit easier to find length of a side. So theta is going to be 140 minus 90 because this whole angle is 140. Can you see that this angle is 90 degrees? Because this is perfectly due east. This direction is east. So therefore this is perfectly due east, so that's a 90-degree angle. So to find that particular theta, I just simply do 140 minus 90, which is 50 degrees. So theta is 50 degrees. Okay. I'll just label that for you. 50 degrees. Now what I'm going to do is, again, use some trigonometric ratios. So you can see that cos 50, cos is adjacent over hypotenuse. See how that's the adjacent side, that's the hypotenuse, and that adjacent side, x, is what we're looking for. So we might as well use cos. So cos 50 is going to be x, the adjacent side, over the hypotenuse 250. Okay? So I've got that now. Solve for x. So x is simply going to be 250 times cos 50. Okay, so just move 250 over to there. And just find it out. Put it into your calculator, guys. You see that's approximately 161. Okay, because it says to the nearest kilometre. So just put it to the nearest kilometre. 161. Therefore, the ship is 161 kilometres east of Sydney to the nearest kilometre. Okay, so that distance here, this distance is 161. Alright. Have a look, guys. I'll rub this off. So see how using the diagram really helped us to get to the final answer? So have a look at that now, guys. And let's move on to the next question. So question 5, a plane flies north from town for 400 kilometres, then turns and flies east for 300 kilometres. What is its bearing from town to the nearest degree? Okay, so let's interpret the question again. I'm going to put it as a diagram. A plane flies north from town. So if this is a town, okay, it flies north from town, so directly north. Okay, so it's going to be like a 0 degree bearing, so it's just going to be directly north, and that's going to be 400 kilometres. Okay, that gives you a length. And then it turns, so we're here now at north, and flies east for 300 kilometres. Okay, so directly east. So if I draw a north from that position, directly east would be on a bearing of 90 degrees, isn't it? Yeah, so if this is east, and it says for 300 kilometres, 300. So it goes directly north, then directly east. Okay, so we're going to have a lot of 90 degrees here. Now it says, what is the bearing from town to the nearest degree? From town. So from town to the nearest degree. So this is our finishing point, isn't it? That's our starting point. So if I just like to draw a line through there, starting point, finishing point, that's the starting point. So the bearing we always calculate from north in a clockwise direction. So that will be our angle or the bearing we're looking for, isn't it? Okay, I'll just give you a better diagram. That's what it's going to look like. Okay, mine's a bit messy. So starting from here, goes up 400 kilometers, turns east through 300 kilometers, and that's the bearing we want to look for. Okay, basically what I drew, but mine's a little bit messy. So I'll just rub this off. Okay guys, have a look. So we're going to use that diagram to try and approach the question. So we're looking for that angle. We've got two different sides, and hopefully you can see that this is 90 degrees because it goes directly east, directly north. So that's going to be 90 degrees. So what I'm going to do is use my trigonometric ratio of tan. Because look, from that angle we've got opposite side and the adjacent side, so we might as well use tan. So tan theta is going to be opposite 300 over adjacent 400. Okay, now just simplify that to 3 on 4. Just simplify as you go. So tan theta is 3 on 4, so therefore to find theta we do tan inverse 3 on 4. Okay, so tan inverse 3 on 4, just press shift tan 3 on 4 into your calculator, see what you get. Hopefully you get the same as mine, 36 degrees and 52 minutes. Okay, so therefore that's the theta. Now bearing is going to be simply 0.37 degrees. This is basically to the nearest minute 37 degrees, isn't it? Yeah, so I'm going to write that as 0.37 degrees. Okay, have a look at that, guys. Make it into a 3-digit number all the time for bearings. That's basically it. Okay, have a look, guys. Hope you're getting more used to these diagrams because I showed you all these steps from drawing the diagrams by interpreting the questions. So hopefully you're good at those now. Have a look. That was question 5 and that was bearings.